Welcome to Galaxy Guru, your ultimate guide to the galaxies that shape our universe. Thank you for joining me. My name is Gino, and today we're diving into a cosmic colossus that redefines everything we know about the universe. A galaxy so massive it could swallow our Milky Way whole and still have room for dessert. That's right. We're stepping into the realm of the unimaginable to explore a discovery that has astronomers gasping in awe. Picture this: a galaxy stretching millions of light years across space. A titan packed with trillions of stars. This is IC 1101, the most massive galaxy in the universe. A cosmic giant that's been hiding in plain sight, waiting for us to uncover its secrets. Let's set the scene. It's over 1 billion light years away. A distance so vast that the light we see today left it when Earth's first complex life was just crawling out of the oceans. Yet, this isn't some faint flickering speck in the sky. IC 1101 blazes with the fury of 1 trillion suns, dominating an entire galaxy cluster, like a king on a celestial throne. Scientists call it an elliptical galaxy. But that label doesn't even begin to capture the sheer scale and mystery it holds. How was it found? Well, it's a story that takes us back centuries. A tale of curiosity, crude telescopes, and a discovery that would rewrite the cosmic rulebook. Astronomers weren't hunting for a monster like IC 1101. Not at first. They were just peering into the night, trying to map the heavens. Then, something extraordinary caught their eye. A faint blur that refused to fade, a signal from the depths of space that whispered, "Look closer." Now, let's pause for a moment. Imagine the stakes. Galaxies are the building blocks of the cosmos. They're supposed to come in all shapes and sizes: spirals, ellipticals, irregulars. But IC 1101, it's in a league of its own. It's not just big, it's unfathomable. A galactic titan that challenges everything we've ever assumed about how these starry cities form and grow. This is just the beginning. In this documentary, we'll peel back the layers of this cosmic behemoth. We'll explore its jaw-dropping size, its Frankenstein-like structure, and the monster black hole lurking at its heart. We'll uncover how it churns out stars like a factory on overdrive, how dark matter pulls its strings, and its commanding role in the vast cosmic web. And finally, we'll dare to ask, what secrets does IC 1101 still keep locked away? For now, let's start where it all began, with the discovery of a giant that's been watching over the universe for billions of years. Join us as we chase its story through the stars. Let's rewind the clock to 1790. The world is a different place. No electricity, no cars, just candlelight and the boundless curiosity of a man named William Herschel. He's an astronomer with a passion for the unknown, building telescopes in his backyard that rival anything of his time. Night after night, he sweeps the sky, cataloging faint smudges of light, nebulae, star clusters, and what he calls island universes. On one fateful night, in the constellation Virgo, his telescope locks onto something peculiar, a blurry patch that glows ever so slightly against the black. He scribbles it down. A nebula, he thinks, just another cloud of gas in the vastness. But oh, how wrong he was. That faint smudge? It was IC 1101, the most massive galaxy in the universe. But back then, no one had a clue. Herschel saw it through his 40-foot telescope, a marvel of the era, but he couldn't grasp its true nature. Telescopes were too weak. Science was too young. For over a century, that blurry patch sat in the records, waiting for its moment. Fast forward to 1895. Enter J.L.E. Dreyer, an astronomer with a mission to catalogue the heavens. He compiles the Index Catalogue of Nebulae and Clusters of Stars, IC for short. And there it is, IC 1101, officially named. Still just a fuzzy dot to the naked eye, but now it had an identity. Was it a nebula? A cluster? No one knew for sure. The technology just wasn't there. Then came the 20th century, a revolution in astronomy. Bigger telescopes, better lenses, and a man named Edwin Hubble who turned the cosmos upside down. In the 1920s, Hubble proved those nebulae weren't clouds in our galaxy. They were galaxies, entire worlds of stars millions of light years away. IC 1101 wasn't some local curiosity. It was a distant giant, part of the Abell 2029 galaxy cluster, 1 billion light years from Earth. But its true scale, that stayed hidden until the modern era. In the 1960s, radio telescopes came online, piercing through cosmic dust to reveal what optical lenses couldn't. Astronomers pointed these dishes at IC 1101 and listened. What they heard was staggering. Signals of gas and stars moving at incredible speeds. A galaxy so vast, it defied comprehension. By the 1970s, they had numbers. IC 1101 spanned over 5 million light years, hundreds of times wider than our Milky Way. Its mass? 1 trillion suns worth of stars, gas, and who knows what else. Here's where it gets wild. It wasn't just the size that shocked them. It was the realization that IC 1101 had been growing. For billions of years, it had been devouring other galaxies, merging with them, stealing their stars and gas. A cosmic cannibal, sitting at the heart of its cluster like a predator at a feast. Modern space telescopes, Hubble, Spitzer, Chandra, they've zoomed in closer. They've shown us its elliptical glow, a shape forged by countless collisions. And at its center, a black hole so massive it could eat our sun for breakfast and not even burp. So how did we go from a faint smudge in Herschel's notes to the king of all galaxies? It's a story of patience, of technology, of humans refusing to stop asking questions. IC 1101 wasn't found by accident. It was revealed by persistence. And now, it's ours to explore. Now, friends, time to begin to tackle the mind-bending question. How big is IC 1101 really? Can we even wrap our heads around its scale? And what does its size mean for the universe we live in? I hope you're enjoying and stick with me as we dive deeper into this galactic titan. Okay, so far we have uncovered how IC 1101, the most massive galaxy in the universe, was discovered. A faint smudge in the night sky that turned out to be a galactic titan. Next, we're tackling the question that's probably burning in your mind. Just how big is IC 1101? Really? Buckle up, because we're about to stretch your imagination to its limits. Let's start with a number that's hard to wrap your head around. IC 1101 spans over 5 million light years across. That's not a typo. 5 million light years. To put that in perspective, our own Milky Way, the galaxy we call home, is a mere 100,000 light years wide. That means IC 1101 is 50 times larger than the Milky Way. If the Milky Way were a basketball, IC 1101 would be the size of a football field. It's not just big, it's incomprehensibly vast. But size isn't just about width, it's about mass. IC 1101 is estimated to contain the mass of 100 trillion suns. That's 100 trillion suns. If you tried to count that many stars, one per second, it would take you over 3 million years. And that's just the stars. Add in the gas, dust, and dark matter, and IC 1101's total mass is staggering. It's like the universe decided to cram every spare bit of matter it could find into one galactic giant. Now, here's where it gets even wilder. IC1101 isn't just sitting alone in the void. It's the crown jewel of the Abell 2029 galaxy cluster, a massive group of over 1,000 galaxies all bound together by gravity. Imagine a city of galaxies, and IC 1101 is the towering skyscraper at its center, dwarfing everything around it. In fact, IC 1101 is so large that it could swallow hundreds of smaller galaxies whole, and it probably has. Let's zoom out for a second. The Milky Way is part of the local group, a modest collection of about 50 galaxies. The local group itself is part of the Virgo supercluster, which contains thousands of galaxies. But Abell 2029? It's on another level. It's one of the most massive galaxy clusters in the universe, and IC 1101 is its beating heart. This isn't just a galaxy, it's a galactic empire. So how did IC 1101 get so big? The answer lies in its history of cosmic cannibalism. Over billions of years, it's been merging with other galaxies, stealing their stars, gas, and dust. Each collision adds to its bulk, like a snowball rolling downhill, growing larger with every turn. Astronomers believe IC 1101 has been doing this for over 10 billion years, making it not just the largest, but one of the oldest galaxies we know. But size isn't everything. What makes IC 1101 truly fascinating is how it looks. Unlike the spiral galaxies we are used to, with their graceful arms and bright centers, IC 1101 is an elliptical galaxy. That means it's shaped like a giant stretched out football, with stars spread out in a smooth, featureless glow. No spiral arms, no star-forming regions lighting up the night. Just a vast, diffuse sea of ancient stars, glowing softly across millions of light years. Here's a question for you. How do you even measure something this big? Astronomers use a technique called surface brightness profiling. They look at how the light from the galaxy fades as you move from the center to the edges. For IC 1101, that light doesn't drop off quickly. It stretches out and out and out, revealing just how enormous this galaxy truly is. It's like trying to find the edge of a fog bank that never ends. And speaking of edges, IC 1101 doesn't have a clear boundary. Its outer regions blend into the surrounding cluster, making it tricky to say where the galaxy stops and the cluster begins. It's as if IC 1101 is the king, and the other galaxies are its loyal subjects, all part of one massive cosmic kingdom. Let's try to visualize this. Imagine standing on a planet in IC 1101. Though, fair warning, you'd probably be vaporized by radiation or crushed by gravity. But if you could, the night sky would be unlike anything you've ever seen. Instead of a few thousand stars, you'd see millions, packed so densely that the sky would glow with a soft golden light. And beyond that, the faint outlines of other galaxies, all part of the same cluster, stretching across the heavens like a web of light. But here's the kicker. Despite its size, IC 1101 is surprisingly faint. Its stars are spread out over such a vast area that its surface brightness, the amount of light per square arcsecond, is incredibly low, That's why, even though it's the largest galaxy, it's not the brightest. It's like a giant ghostly presence in the universe, too big to ignore, but too diffuse to dominate the night sky. So, what does this mean for us? Well, IC 1101 challenges our understanding of how galaxies form and evolve. It's a relic from a time when the universe was younger, wilder, and galaxies were still figuring out their place in the cosmos. By studying it, astronomers hope to unlock the secrets of galaxy formation, how they grow, merge, and eventually die. Next, we'll dive into the strange structure of IC 1101. Why does it look like a cosmic Frankenstein, stitched together from the remnants of other galaxies? And what does that tell us about its past? By the way, thanks for joining me on another journey through the cosmos. If IC 1101's size has blown your mind, hit that subscribe button and ring the bell to keep in touch for more videos. Okay, so we have tackled the jaw-dropping size of IC 1101, the most massive galaxy in the universe, stretching over 5 million light-years across. Now, it's time that we dive into its bizarre structure. Why does IC 1101 look like a galactic Frankenstein, stitched together from the remnants of other galaxies? And what does that tell us about its violent past? Let's find out. Let's start with a question. What do you picture when you think of a galaxy? Maybe a spiral, like our Milky Way, with graceful arms swirling around a bright center. Or perhaps a perfect ellipse, glowing with stars. But IC 1101? It's neither. It's a galactic Frankenstein, a chaotic, misshapen giant that looks like it was cobbled together from the pieces of 100 shattered galaxies. And in a way, it was. IC 1101 is classified as an elliptical galaxy, but that label doesn't do it justice. Elliptical galaxies are usually smooth, featureless blobs of stars. They're the retirees of the cosmos, old, quiet, and done with the drama of star formation. But IC 1101 is different. It's not just elliptical, it's a supergiant elliptical, and its structure is anything but simple. So, what makes it so strange? For one, its shape. While most elliptical galaxies are like stretched out footballs, IC 1101 is more like a bloated, uneven pancake. It's flattened, with a disc-like structure that hints at a turbulent history. Astronomers believe this odd shape comes from its past as a cannibal, devouring smaller galaxies and absorbing their stars, gas, and dust. Each merger left its mark, stretching and distorting IC 1101's form into the cosmic hodgepodge we see today. But it's not just the shape that's weird, it's the way its stars are distributed. In a typical galaxy, stars are packed tightly in the center, with density dropping off toward the edges. Not in IC 1101. Its stars are spread out in a vast, diffuse halo, like a fog that never quite clears. This makes it hard to tell where the galaxy ends and the surrounding space begins. It's as if IC 1101 is bleeding into the universe, its boundaries blurred by billions of years of growth. Here's where it gets even stranger. Unlike spiral galaxies, which are full of young, bright stars and glowing nebulae, IC 1101 is a ghost town. Its stars are old, ancient even. Most of them formed billions of years ago, and now they're just coasting along, their light dimming with age. There are no star-forming regions lighting up its core, no spiral arms churning out new suns, just a vast, quiet sea of elderly stars glowing with a soft golden light. But don't let that fool you. IC 1101 isn't dead, it's just resting. Deep within its heart, There's a monster waiting to wake. A supermassive black hole, billions of times more massive than our Sun, sits at the center, quietly pulling the strings. We'll dive into that beast shortly, but for now, let's focus on the galaxy's structure. So how did IC 1101 end up looking like this? The answer lies in its history of cosmic collisions. Over billions of years, it's been involved in countless mergers, smashing into other galaxies, absorbing their stars, and growing ever larger. Each collision scrambled its structure, erasing any spiral arms or neat patterns, leaving behind this chaotic, elliptical blob. Think of it like a snowball rolling down a hill. It starts small, but as it picks up more snow, it grows bigger and more misshapen. IC 1101 is the same. Each galaxy it swallowed added to its bulk, but also to its disorder. That's why it looks like a Frankenstein's monster of the cosmos, stitched together from the remnants of its victims. But here's the kicker. IC 1101 might not be done growing. It's still at the center of the Abell 2029 cluster, surrounded by hundreds of smaller galaxies. And gravity is relentless. Over time, it could pull in even more galaxies, merging with them and growing even larger. Could IC 1101 become the universe's ultimate galactic predator? Only time will tell. For now, its strange structure is a window into the past. By studying IC 1101, astronomers can piece together the history of galaxy formation, how smaller galaxies merge to form giants, and how the universe's most massive structures come to be. It's like reading the scars of a warrior. Each mark tells a story of battles fought and won. Next, my friend, we'll meet the beast at the heart of IC 1101. Its supermassive black hole. How big is it? What role does it play in shaping this galactic titan? And could it be the key to understanding the galaxy's future? Let's get right into it. Seems like we stepped into a cosmic mystery that's rewriting everything we thought we knew. So far, we explored the bizarre Frankenstein-like structure of IC 1101. The most massive galaxy in the universe, stitched together from the remnants of countless cosmic collisions. Now, it's time to dive into the heart of this galactic titan to meet the beast that lurks within. A supermassive black hole so enormous it could swallow our entire solar system without a trace. Let's unravel the mysteries of this cosmic monster. Let's start with a chilling fact. At the center of IC 1101 lies a black hole so massive, it makes the one at the heart of our Milky Way look like a pebble next to a mountain. This isn't just any black hole, it's a supermassive black hole, and it's one of the largest ever discovered. Its mass? A staggering 50 billion times that of our Sun. That's 50 billion suns packed into a single point of infinite density. If you think that's hard to imagine, you're not alone. This black hole is so big, its event horizon, the point of no return, stretches wider than the orbit of Neptune. Anything that crosses that line is lost forever, pulled into the abyss by gravity so strong, not even light can escape. But size isn't the only thing that makes this black hole terrifying. It's the silent puppeteer, controlling the fate of the entire galaxy from its dark throne. Every star, every planet, every speck of dust in IC 1101 dances to the tune of its gravitational pull. And yet, despite its power, it's invisible. A shadow in the void, detectable only by the chaos it leaves in its wake. So how did this beast come to be? The truth is, we're not entirely sure. Supermassive black holes are one of the universe's greatest mysteries. Some scientists believe they form when smaller black holes merge over billions of years, growing larger with each collision. Others think they might be born from the direct collapse of massive gas clouds in the early universe, skipping the star stage entirely. For IC 1101's black hole, it's likely a combination of both. Feasting on the remnants of the galaxies IC 1101 has devoured over its long, violent history. Here's where it gets even wilder. This black hole isn't just sitting there, passively growing. It's actively shaping the galaxy around it. Its immense gravity pulls stars into tight orbits, flinging some into the void and tearing others apart in a process called tidal disruption. Imagine a star, minding its own business, suddenly ripped to shreds by the black hole's pull, its gas spiraling into the event horizon in a blaze of light. These events are rare, but when they happen, they light up the galaxy like a cosmic fireworks show. But wait, there's more. This black hole doesn't just destroy, it also creates. When gas falls into it, it heats up, emitting powerful jets of energy that blast across the galaxy at nearly the speed of light. These jets can stretch for thousands of light years, punching through the galaxy's gas and dust, shaping its structure and even triggering new star formation in their wake. It's a delicate dance of destruction and creation, all orchestrated by the black hole at the center. Now, let's talk about scale. The black hole in IC 1101 is so massive that if you placed it at the center of our solar system, its event horizon would swallow everything out to Neptune, and then some. For comparison, the black hole at the center of the Milky Way, Sagittarius, a star, is a mere 4 million solar masses. IC 1101's black hole is over 12,000 times larger. It's not just a beast, it's a titan among titans. So how do we even know it's there? Black holes don't emit light, after all. The answer lies in the stars around it. By studying the orbits of stars near the galaxy's center, astronomers can measure the black hole's gravitational pull. The faster the stars are moving, the stronger the gravity. And in IC 1101, those stars are screaming across the sky at breakneck speeds. It's like watching a swarm of bees buzzing around an invisible hive, their frantic motion betraying the presence of something massive and unseen. But here's the kicker. Despite all we've learned, this black hole still holds secrets. Its exact mass is still debated. Some estimates put it at 40 billion solar masses, others at 50 or even 60. And we don't know how it grew so large. Did it start as a smaller black hole and grow through mergers? Or was it born massive, a relic from the universe's earliest days? The truth is, we might never know for sure. IC 1101 is over a billion light years away, and even our most powerful telescopes can only glimpse its shadows. Yet, the future holds promise. With new tools like the James Webb Space Telescope and the upcoming Vera Rubin Observatory, astronomers hope to peer deeper into IC 1101's core, mapping its black hole's influence in unprecedented detail. Maybe, just maybe, we'll catch a glimpse of the beast itself, or at least, the chaos it wreaks. For now, though, the black hole remains a mystery wrapped in darkness. A silent giant, pulling the strings of a galaxy so vast it defies comprehension. And as we continue our journey through IC 1101, we'll see how this beast shapes not just the galaxy, but the entire universe around it. In the next part, we'll explore how IC 1101 churns out stars like a factory on overdrive. How does a galaxy this old still manage to birth new suns? And what does that mean for its future? Stick with me, the Galaxy Guru, as we dive deeper into the secrets of this cosmic titan. Okay, so we met the beast at the heart of IC 1101, a supermassive black hole so massive it could swallow our solar system whole. Now, we're going to be diving into the galaxy's star factories. How does a galaxy this old still churn out new stars? And what does that mean for its future? Let's find out. Let's start with the paradox. IC 1101 is ancient, older than the dinosaurs, older than Earth itself. And yet, against all odds, this galactic titan is still churning out new stars. How is that possible? You'd think a galaxy this old would be a cosmic retirement home filled with elderly stars coasting toward their twilight years. But IC 1101 is different. It's a star-making machine running on overdrive. So, what's the secret behind its youthful vigor? The answer lies in its history of cosmic cannibalism. Over billions of years, IC 1101 has devoured countless smaller galaxies, absorbing their gas and dust, the raw materials for star formation. Each merger injects fresh fuel into the galaxy, sparking new bursts of star birth. It's like a cosmic recycling plant, turning the remnants of dead galaxies into newborn suns. Without these mergers, IC 1101 would have run out of gas long ago. But instead, it's a galactic phoenix, constantly reborn from the ashes of its conquests. But there's more to the story. Remember that beastly black hole we met in part 4? It's not just sitting there, it's actively shaping the galaxy's future. Its powerful jets of energy blast through the galaxy, heating gas and triggering star formation in some regions. At the same time, its immense gravity pulls gas inward, potentially stifling star birth in others. It's a delicate balance, with the black hole acting as both creator and destroyer. In some areas, the jets compress gas clouds, sparking the birth of new stars. In others, the black hole's pull strips gas away, leaving behind starless voids. It's a cosmic dance of chaos and creation. So how does IC 1101's star formation compare to other galaxies? Let's use our Milky Way as a benchmark. In the Milky Way, stars are born at a steady pace, about 1 or 2 per year. It's a slow, methodical process, like a small-town bakery churning out a few loaves a day. But in IC 1101, it's a whole different story. This galaxy is a star-making juggernaut, churning out suns at a rate that dwarfs our own. Some estimates suggest it could be producing hundreds of stars per year, fueled by the vast reservoirs of gas it's accumulated over eons. It's like comparing a single candle to a blazing inferno. And here's where it gets even wilder. Unlike younger galaxies, where star formation happens in neat, organized spirals, IC 1101's star birth is chaotic. Its mergers have scrambled its structure, creating pockets of gas that collapse into stars in unpredictable bursts. It's not a tidy factory. It's a cosmic wildfire, with stars igniting wherever the conditions are right. But how long can this last? Every galaxy has a finite supply of gas, and once it's gone, star formation grinds to a halt. So, is IC 1101 running on fumes? The truth is, even a galaxy this massive has its limits. Eventually, its gas reserves will run dry, and its star factories will shut down. but that day is still billions of years away. For now, IC1101, excuse me, my apologies for mispronouncing IC1101 sometimes. Anyway, IC1101 remains a cosmic forge, hammering out new stars in the fires of its ancient heart. Here's a question to ponder. Could IC1101's relentless star production hold the key to understanding the universe's future? Or is it just a fleeting moment in the galaxy's long, slow decline? Only time, and perhaps a few more cosmic collisions, will tell. In the next part, we'll explore the invisible force that holds IC1101 together. It's not just stars and gas, there's something darker, something unseen, pulling the strings. We are going to uncover the role of dark matter in shaping this galactic titan. Stick around as we dive deeper into the mysteries of the cosmos. Okay, so we just explored how IC1101, the most massive galaxy in the universe, churns out stars like a factory on overdrive. Now, we're going to be diving into the invisible force that holds it all together. It's not just stars and gas, there's something darker, something unseen, pulling the strings. Let's uncover the role of dark matter in shaping this galactic titan. Let's start with a chilling fact. There's something out there in the universe, something we can't see, can't touch, and can't detect directly. It makes up 27% of the cosmos, dwarfing the mere 5% of regular matter that includes stars, planets, and you. This invisible force is dark matter, and it's the glue that holds galaxies like IC1101 together. Without it, the galaxy's trillion stars would scatter into the void like dust in the wind. But with it, IC1101 stands as a cosmic colossus, its structure shaped by this unseen hand. So, what exactly is dark matter? The truth is, we don't know. It's the universe's greatest mystery. We can't see it because it doesn't emit, absorb, or reflect light. But we know it's there because of its gravitational pull. It's like the invisible scaffolding of the cosmos, holding everything in place. And in IC1101, its presence is undeniable. Here's how it works. Imagine a galaxy as a spinning disk of stars and gas. In a normal galaxy, the stars at the edges should move slower than those near the center, just like planets orbiting the sun. But they don't. They move at the same speed, defying the laws of gravity. Unless, of course, there's something else out there, adding extra gravity. That something is dark matter. It wraps around galaxies in a vast, invisible halo, providing the gravitational scaffolding that keeps everything in check. For IC1101, this dark matter halo is likely one of the largest ever detected. It stretches far beyond the galaxy's visible stars, acting as a gravitational net that holds its trillion suns in place. Without it, IC1101's stars would fly apart, unable to resist the galaxy's own chaotic motion. But with it, the galaxy remains stable, its structure intact despite its mind-boggling size. But dark matter doesn't just hold things together, it shapes them. In IC1101, its gravitational pull compresses gas clouds, sparking the birth of new stars. That's right, even in this ancient galaxy, dark matter is indirectly fueling the star factories we explored in Part 5. It's a cosmic puppet master, pulling the strings behind the scenes, triggering creation in the shadows. And it doesn't stop there. Dark matter also stabilizes the galaxy's core, where its supermassive black hole resides. Without dark matter's gravitational embrace, the black hole's chaotic influence could tear the galaxy apart. Instead, it's held in check, allowing IC 1101 to maintain its delicate balance of destruction and creation. So, how do we know dark matter is there? We can't see it, but we can see its effects. By studying the motion of stars and gas in IC 1101, astronomers can map the galaxy's gravitational field. The faster the stars move, the stronger the gravity. And in IC 1101, those stars are moving at breakneck speeds, far faster than visible matter alone could explain. It's like watching a marionette dance, its strings pulled by an unseen hand. Here's where it gets wild. IC 1101's dark matter halo might be so massive that it warps the fabric of space-time around it, bending light from distant galaxies in a phenomenon called gravitational lensing. Imagine looking through a cosmic magnifying glass where the galaxy's dark matter distorts the light of objects behind it. This effect not only confirms dark matter's presence, but also lets us study its distribution, mapping the invisible. But despite all we've learned, dark matter remains a mystery. We don't know what it's made of. Some think it's exotic particles, like WIMPs, weakly interacting massive particles, or axions. Others wonder if it's not particles at all. Maybe it's a tweak in how gravity works. For now, it's the universe's best-kept secret. And IC 1101 is one of its grandest stages. In the next part, we'll zoom out to explore IC 1101's place in the cosmic web. How does this galactic titan fit into the universe's largest structures? And what does it tell us about the fate of galaxies billions of years from now? Let's go dive into the cosmic architecture that shapes our universe. Let's start with a mind-bending concept. The universe isn't just a random scatter of stars and galaxies. It's a structured masterpiece, woven together by an invisible web. This is the cosmic web, the universe's skeleton, a vast network of filaments made of dark matter and gas, connecting galaxies like beads on a string. It's the scaffolding that shapes the cosmos, guiding the flow of matter and the birth of galaxies. And IC 1101, it's not just part of this web, it's a kingpin, sitting at the heart of one of its most massive knots. So, what exactly is the cosmic web? Picture a spider's web, stretched across the void. The threads are filaments of dark matter, invisible to our eyes but detectable through the gravitational pull. Where these filaments intersect, they form dense regions, galaxy clusters, the bustling cities of the universe. And within these clusters, galaxies like IC 1101 reign supreme. Now, let's zoom in on IC 1101's domain. It's the crown jewel of the Abell 2029 galaxy cluster, one of the most massive clusters in the known universe. Abell 2029 is a cosmic metropolis, home to over 1,000 galaxies, all bound together by gravity. But IC 1101 isn't just another resident, it's the undisputed ruler. It sits at the cluster's center, its gravitational pull so strong that it shapes the entire structure, pulling smaller galaxies into its orbit like a king commanding his court. Here's where it gets wild. Galaxy clusters like Abell 2029 are the knots in the cosmic web, the points where dark matter filaments converge. These clusters are the universe's construction sites where galaxies merge, grow, and evolve. And IC 1101 is the ultimate product of this process, a galactic titan forged through billions of years of cosmic collisions. So, how did IC 1101 become the king of its cluster? The answer lies in a process called hierarchical structure formation. It's like a cosmic game of snowball. Small galaxies merge to form larger ones, which then merge to form even larger ones, and so on. IC1101 is the endgame of this process, having swallowed countless smaller galaxies over its lifetime. Each merger added to its bulk, making it the behemoth we see today. It's not just a galaxy, it's a galactic empire, built on the bones of its conquests. But here's the kicker. IC1101 might not be done growing. As the central galaxy in Abell 2029, it's still pulling in smaller galaxies, merging with them and growing even larger. It's a cosmic predator, and the cluster is its hunting ground. Could IC1101 become even more massive? Or is it approaching its final form? Let's ponder the future. What does IC1101's place in the cosmic web tell us about the fate of galaxies? Well, galaxy clusters like Abell 2029 are dynamic systems. Over time, their galaxies interact, merge, and evolve. Eventually, many clusters will see their central galaxies, like IC1101, become fossil galaxies, relics of a time when star formation was rampant. These fossils are quiet, with the little new star birth coasting through the cosmos on the remnants of their past glory. But IC1101 isn't there yet. As we saw in Part 5, it's still churning out stars, fueled by the gas it's stolen from its victims. However, this can't last forever. Eventually, its gas reserves will run dry, and its star factories will shut down. When that happens, IC1101 will fade into a ghostly giant, its trillion stars slowly dimming over eons. Here's a question for you. What does IC1101's dominance tell us about the universe's future? As galaxies merge and clusters grow, could the cosmos eventually be dominated by a handful of supergiant galaxies like IC1101? Or will dark energy tear the cosmic web apart before that can happen? The truth is, we don't know. But studying IC1101 gives us a glimpse into one possible future, a universe of titanic galaxies, each a graveyard of stars. For now, IC1101 stands as a testament to the universe's grand design. It's a king in the cosmic web, a ruler of its cluster, and a window into the processes that shape galaxies on the largest scales. And as we continue our journey, we'll see what secrets it still holds. In the next part, we'll explore the mysteries IC1101 still hides. What unanswered questions linger in its depths? And what could they tell us about the universe's past and future? Stay tuned to Galaxy Guru as we dive deeper into the secrets of this cosmic titan. Thanks for joining me on this journey through the stars. If IC1101's place in the cosmic web has you hooked, smash that subscribe button and ring the bell for more. I appreciate your support. I hope you are enjoying your day or evening, wherever you are. We're diving into the final frontier, the secrets IC1101 still hides. What unanswered questions linger in its depths, and what could they tell us about the universe's past and future? Let's find out. Let's start with a chilling thought. Despite all we've learned about IC1101, its staggering size spanning over 4 million light-years, its Frankenstein-like structure forged from countless mergers, its monstrous black hole, and its ancient star factories, there's still so much we don't know. This galactic titan is like a cosmic vault, locked tight with secrets that could reshape our understanding of the universe. So, what are the biggest mysteries IC1101 still holds? And how close are we to cracking them? First, there's the question of its dark matter halo. Dark matter is the invisible glue keeping IC1101's massive structure intact. But we don't know how it's distributed. Is it a smooth, uniform shroud enveloping the galaxy, or a clumpy, chaotic mess? How does it interplay with the galaxy's visible stars and gas? Scientists speculate that unlocking IC1101's dark matter secrets could shed light on what dark matter actually is: exotic particles, or perhaps something stranger. For now, it remains a shadowy puzzle. Next, there's the mystery of its supermassive black hole. Weighing in at an estimated 50 billion solar masses, it's one of the largest ever discovered. But how did it get so enormous? Did it grow gradually through mergers of smaller black holes? Or was it born massive in the universe's chaotic infancy? What's its fate? Could it one day devour IC1101 entirely? Or will it hold the galaxy in a stable gravitational embrace for billions of years? These questions haunt astronomers, and the answers are still out of reach. But here's where things get wilder. IC1101 isn't just a standalone giant. It's the beating heart of the Abell 2029 cluster, surrounded by hundreds of smaller galaxies. Its role in the cluster's dynamics is murky. How does its colossal gravity dictate the motion of these orbiting galaxies? Could it be sculpting the intracluster light, that eerie glow from stars torn from their homes, drifting in the cluster's void? Picture it. IC1101 as a cosmic grim reaper, stripping stars from neighboring galaxies and scattering them into a ghostly graveyard. The unexpected twist: cluster dynamics. Now, here's the unexpected detail that makes IC1101 even more mind-blowing. It's not just passively sitting at the cluster's center, it's actively shaping the entire Abell 2029 cluster's evolution. Recent studies reveal that IC1101's immense gravity warps the orbits of smaller galaxies, stretching them into elongated paths like a cosmic slingshot. This process, known as dynamical friction, slows these galaxies down, dragging them closer to IC1101 over time. Some even get devoured, fueling its growth. It's a galactic tug-of-war, and IC1101 is the reigning champion. This dynamic could explain why it's ballooned to such an outrageous size while its neighbors stay relatively small. And here's a jaw-dropping implication. This might mirror the future of our own Milky Way. In billions of years, when the Milky Way merges with Andromeda, we could evolve into a massive elliptical galaxy like IC1101, potentially dominating our own local cluster. Is IC1101 a preview of our cosmic destiny? Another big question: is IC1101 still expanding? Is it actively swallowing nearby galaxies? Or has it settled into its final, titanic form? Some astronomers argue it's still in a feeding frenzy, merging with smaller neighbors, while others suggest it's entered a quieter phase, its growth stunted. The catch? At over 1 billion light-years away, we're seeing IC1101 as it was eons ago. To confirm its current state, we'd need to observe it for millions of years, a cosmic waiting game we can't play. Exotic secrets to the core. Could IC1101 be hiding something even stranger? Its sheer scale and the extreme conditions at its core make it a perfect lab for exotic physics. Might it harbor unknown particles or exotic matter that defy our current models? Some speculate it could hold clues to dark energy or the fabric of space-time itself. If so, IC1101 isn't just a galaxy. It's a key to the universe's deepest mysteries. Let's consider the future of exploration. So, what's next? New tools like the James Webb Space Telescope could zoom into IC 1101's core, mapping its black hole's influence and star formation in stunning detail. The upcoming Vera Rubin Observatory might chart the cluster's dark matter with unprecedented clarity, revealing how it props up IC 1101's structure. Yet, even with these advances, some secrets may stay buried. That's the allure of the cosmos. It keeps us guessing. As we wrap up this documentary, IC 1101 stands as more than a galaxy. It's a window into the universe's epic story. It shows us how galaxies are born, grow, and merge, sculpted by forces both visible and hidden. It's a monument to the universe's capacity for grandeur and a challenge to keep exploring. The secrets it still hides remind us there's so much more out there waiting to be discovered. Thank you for joining me on this stellar journey. If IC 1101 has sparked your cosmic curiosity, smash that subscribe button and ring the bell for more adventures among the stars. And leave a comment telling us what you would like to hear about in future videos and documentaries, or just to share your thoughts. Thank you again. Until next time, never stop learning and always keep your eyes on the cosmos.